back yesterday, we were talking about alcohols. And I talked about 3 ways to get repair some alcohols. There's a 4th way, and that's a big blank sheet you have there that says fermentation on the top. That's one we already mentioned, but we're going to obviously come back to it today and the rest of this week. I have to be away tomorrow. I'll be in the building, but I'll be at a training thing. So I can't do it tomorrow. But tomorrow we're going to finish, or Thursday we're going to finish that lab. We're going to finish that fermentation lab. That's another way I can make an alcohol. And the way I want you to, in order for our reaction to work best, as far as we're going to do some calculations and everything else with you, we added sucrose. That's what you measure the mass of. All right, but when you put it in water, it's hydrated. So that's what the reaction is going to look like. All right, and you can write this down under your fermentation reaction. That way, this will work best for our calculations. And you can finish that reaction. What are the 2 things we get from that? What do you think? Think about why we originally talked about. Why did we originally talk about fermentation? I wasn't talking about alcohols. What was I talking about? What was produced? What was produced over there? Carbon dioxide, yeah. That's why I originally started those labs. Now, I knew we'd get to alcohols eventually, too, and be able to talk about it again. But, yeah, we get C2H5OH, which is ethanol, and carbon dioxide. Now, I have it written out as the molecular formula instead of the structural formula. You could, but don't do this. What is C2H5OH? It's just this. The way we've been writing it. I said don't do that because you have to name everybody underneath this anyway. But that's the same stuff. All right? It's just written a different way. See why? C2, C2, H5, 1, 2, 3, 4, 5, OH, OH. That's the same thing as that. You have to get used to seeing things written in multiple ways. All right? This is not balanced. You should balance this on your own. I don't need to balance that. It's not that hard for you. All right? But you notice the rest of your paper is blank. That's where you're going to put your notes for the rest of this lab. You have written, I think, somewhere else a couple of days' worth of observations, and your first day of the fermentation lab, you wrote some notes down, some procedural notes, some observations, and some pictures. You even drew the picture of that. Well, you're about to do tomorrow, well, not tomorrow, but Thursday, you're about to do the second half of this lab, and you're going to need to take a lot more notes. That's why that paper is there, and that's why it's blank. So you can put the rest of your stuff there. Eventually, you're going to put all this into a lab report. I'll show you how to do that on Friday. I'll probably give you at least one other day, one other period to work on it. I'll borrow the computers, labs, and I'll bring them in here, and you can have a chance to start typing it. And because it is going to have to be typed, it's going to have to be a long lab report. I'll talk about all the stuff that's going to have to go into it. All right, but that's if you look in your notes where this falls. A lot of times we lose perspective when we get like down into the next rest of this week. Pretty much, we're going to be talking about this particular reaction and making alcohol and then separating it. Mainly, we're about separating that alcohol. Don't forget, this is number 4 underneath preparation of alcohols. Okay, all right. Now, normally at this point, I'd be doing a lot of stuff to get you ready for that lab. Like I said, I'm not going to be here tomorrow. So I'm going to do something a little differently. I'm going to go right to the next notes that are on reactions of alcohols. Okay, I'm going to give you those right now. So it won't take me long, maybe about 15 minutes. I have a little demo to do for you again. Then I'm going to show you a video I always show you about the distillation we're going to be doing. And tomorrow, when I'm not here, I can leave for you a worksheet, another worksheet. Oh, by the way, speaking of which, pass those worksheets up you're supposed to have done for today. Pass those up. For those of you hoping to get away with that. Bailey. And you guys actually had a little bit more time as usual in the other class if you have these 2 periods that are a little bit longer. Although when the announcements go long, it doesn't help you much. The other class barely got 1 or 2 of these done in class. You had time to work on it a little bit on Friday and time to work on them yesterday as well. So my guess is, even if you didn't remember to do them, you probably only don't have the background. Hopefully the other class remember to do them, otherwise they won't have a whole heck of a lot done. All right, let's talk about the reactions of alcohols. I have a little demo that goes along with this. It's kind of neat. So remember, we talked about how to make alcohols. They're going to be on the right-hand side. The product's going to be an alcohol. Now we're going to do reactions of alcohols. They're going to be on the left-hand side. What can I do to it? I can dehydrate it. I can dehydrate an alcohol. What does that mean I'm going to lose from that? Water, right? H2O. dehydration. You're dehydrated, you don't have water in it. Okay? That's what the formula looks like. You take your alcohol, and you're going to get an alkene from him. Now, there are rules about where these things go. Okay? Given a choice, I hope I've made this clear already. Things tend to go more towards the center of the chain. All right? So, for example, and sometimes there is no choice. All right? If I have, don't do this one, but if I had a guy that was just like this, and I remove the OH, all right, the double bond has to go there. Okay, same thing's even true if it's a little bit longer. All right, if it was here, it's still the double bond will have to go there if the OH were over here. However, if the OH were here and given a choice, you're going to get a mixture, but where do you think the double bond is more likely going to form? And I would like you to form the more predominant product towards the middle. Okay, it's just more stable that way. Okay. So if I were to do an example like that guy, say I did this one right here, where the OH is on this one, you could draw this one down, and I were to dehydrate him. What is it underneath that dehydration? Is there anything underneath your thing there? Sulfuric acid, perhaps? Yeah, it is H2SO4. See it there? Is it under yours now? I just want to make sure. It's above. Well, either way, above or below, it doesn't matter. That's what I'm going to do in my demo. I have some concentrated sulfuric acid, which I don't use very often. Matter of fact, we use it in 2 places today, and in the ester lab we're going to use it. Concentrated sulfuric acid this year. Chem 1, we didn't use it at all. I think we used dilute sulfuric acid once or twice, but never concentrated. It's very, very strong, nasty stuff. All right, what do you think is going to happen here? I'm going to get an alkene. And again, although I can get a choice, although there will be more than one product, the most likely product would be the double bond in the middle. And I would get water. Because what happens is the OH and an H from a neighboring carbon are removed. And if I do that, if I take those off, I want you to just think about this. If I take this guy off and this H off, what will happen is I form a double bond at this point. Okay, because now I'd only have 2 H's on this side and 1 H on that side, right? That's what's going to happen. Don't do that because it'll confuse you, but that's what happens over there. Can you name everybody here? I hope so. This would be 2-butanol, right? And this guy would be 2-butene. Okay, everybody good with that? Now, I am going to do this demo for you at the end of the notes. There's only a little bit more notes to give you today. I told you there's only about 10 or 15 minutes worth of actual notes. I'm going to do that in the fume hood in a little bit, but obviously I don't want to stop the camera. I'm going to just finish the rest of the notes up right now. Okay? But everybody's all right with that? You're going to get another worksheet like the one you got before tomorrow. The worksheet's going to include, that one only had alkanes and a little bit of alkenes. This one's going to also have, the new worksheet tomorrow, going to also have alcohols. All the ones we got yesterday, all the ones we're getting today. All right, so you have to be able to finish these, complete these, balance these, and name these. Most of them don't need balancing, but some do. Okay? The compound I'm going to use is going to be this one. I'll come back to that in a little bit. Anybody have an idea what that is? Just curious. It's got all those OHs on it, and it's got carbons on it. So you might think it's an alcohol, but you'd be surprised what that compound is. Anybody figure it out? Nobody? How many? Let's just see if we can figure it out from just an interesting little thing here. This is a carbon, right? Carbon, 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 carbon. Right? How many carbons are there? Yeah, how many H's, how many O's? What do you think this compound is? Sugar. Sugar, yeah. It's just sugar. It's we're going to use this as part of my demo. Sugar is not technically an alcohol, but it will be dehydrated the way I'm going to do it in the fume hood. And dehydration just means removing the OH, removing the water from it. And there's lots of OHs in sugar. Obviously, sugar is, C6H12O6 or C12H22O11. You're just missing one water from there already. We're joined together right here. two glucose molecules. All right, we're going to use that later, but I'm not going to do that right now because I want to keep the camera rolling. All right. Next reaction. Reaction with hydrogen halides. All right, if I take an alcohol and I react with that, can you see what's going to happen here? Again, by now we should just be able to look at the general formula and tell what's going to happen. The OH reacted with an HX, all right, the X is going to take the place of the OH, right? And that H is going to get together with the OH. HOH is water, okay? And in the presence of zinc chloride, that's the catalyst. So let's do an example of that guy. If I had this one on here, I don't think I have an example. No, I don't. If I have this guy on here, I want to do one here where I'm going to do this on the worksheets. Where I've got other things named. You know, I don't want to just keep giving you a simple ethane every time or butane every time. I'm going to have other things on them. You have to know which side to name them from. You have to know what to do. You have to know where the things are going to go. All right. Why don't you try finishing that one on your own and see if you don't make any mistakes? Because if you're making mistakes, if you're just following, writing down what I'm writing down now. When you get these worksheets tomorrow, I'm not going to be here to help you tomorrow. You're going to have to finish that worksheet on your own, and you're going to make the same mistakes. Okay, let's see if you got this. Did you get that? Okay. And you didn't forget the methyl group over here, which people do a lot. You wrote it down. This guy, you have to number him from this side. He would be 1, 2, 3, 4 methyl, 1 pentanol. This guy would be 4 methyl, 1 fluoro. I'm running out of room here. Pentane. Right? Is that good? Did we get that? For the names? Okay. Hopefully you did.
Wait.
No?
Wouldn't it be 1,4,4-methylpentane?
Again, it doesn't matter. I don't care which one you put in order. Alphabetical order really is where you would put them, regardless of numbers. Yeah, F does come before M, so yeah, but it doesn't matter. I'm not going to take off for that. I said that before. Okay. So I would take off if you called it 2-methyl-4-fluoro, because that's the wrong numbering. Okay? All right. By the way, I just want to say this right now. You know, when synthesis ones are going to become the real problem here. On the back of that sheet, I went over it yesterday with you guys and the other class. I'm going to tell you how to make things. Sometimes it's going to take 1, sometimes 2, sometimes 3 or 4 steps. Sometimes I think one of them is even 5 steps long to maybe be able to make a compound. One of the problems you have is making primary things, like a primary alcohol. Because if I take a guy like this, and I put a double bond on here, and I react him, where does the OH have to go? It's not a choice. Where's that OH going to go? Is it ever going to go on the end here? No, that's Markovnikov's rule. So if I say you can start with anything, all right, and I want to get a fluorine on the end here, things don't go on the end. They want to go. If I was from a double bond, he would have gone here. So if I say you can start with anything, you could choose an alcohol. You could choose a primary alcohol already, and that will put it on a primary carbon. This fluorine would want a primary carbon. So that's a neat little trick to be able to do that. If you have your choice, and I will often say, from any alkane or from any alcohol, make this. You can pick the one you want, and then make whatever it is you need. All right. Replacement with active metals. This one's an interesting one. And it's also the last one on the sheet, right? Okay, so I told you it wouldn't take me long. This one is going to give me a compound I haven't learned how to name yet. He's called an alkoxide. I know, great name. You can write that down. Is it already written down there? Okay. It's called an alkoxide. And RON, like a CD-ROM. Your alkyl group, an oxygen, and the M stands for some active metal. Sodium, potassium, magnesium, or aluminum are the ones that do this the best. There may be others, I'm not sure, but those are the ones I looked up. So that's what you would see on the test. It's not like you have to memorize those four. It'll be a metal. Okay, you know what a metal looks like. So if I gave you, for example, this one, and I will use the easy one on this one. Can you figure out, just from the general formula, even though you don't even know how to name this thing yet, can you figure out what's going to be made there? I hope you all did this. Did you? Make sense? Now, this is one of the few, there aren't many, but do you notice something about this guy before I go on to the naming? Is he balanced? No. See, one sodium replaced one H over here. But hydrogen is diatomic, as we all know. So there's H2 over here. When I write hydrogen by itself, it's always H2. So I actually have to put a 2 in front of here, here, and here in order to balance them all out. Now, naming isn't a problem here. What's this guy's name going to be? What do you think? Methanol? But this guy over here is called sodium methoxide. Hence the term alkoxide. Alkane, alkyl group, oxide, sodium methoxide. Now, I actually show you this reaction for a very good reason. You need this guy, you need to be able to make an alkoxide in order to make an ether, which we're going to learn how to do later too. All right, this guy, in other words, you'll have to go through a reaction. And by the way, I want you to think about this, okay? Say I wanted you to make an ether. I'm telling you the starting point will be using this guy and something else. But if I said to make it from an alkane, what would you have to do? This isn't an alkane. You have to make this guy from the alkane. Is there any way to make an alkane into an alcohol directly? No. You'd have to turn him into an alkene. And then, well, there's other ways. You could also turn him into a halogenated alkane. And then turn them into the alcohol, and then turn the alcohol into this, and then add that to something else to get the ether. All right, so you see what I'm saying? These synthesis ones are going to get harder. The ones tomorrow are going to be like this. Okay? If I wanted you to make this, think about this. Say I asked you on tomorrow's, I think I do, ask you to make it sodium methoxide or something like that tomorrow from an alkane. Can you just take, oh, okay, here's methane plus sodium gives me sodium. Can I do that? No, I've got to take my methane and somehow turn him into an alcohol. There's no way to do that directly. But you can turn him into a halogenated alkane, and then a halogenated alkane into an alcohol, and then the alcohol into this. So it'll take you 3 steps to do that if I give it to you tomorrow. You see what I'm saying? It's not easy. These synthesis ones are going to get tough. All right. That was the last one on there, right? Okay. Now let me do the